Now we're on to limits. So I'm going to use this example, this 51, to get through a lot of information, a lot of review information. So the first thing for a limit is if you can do direct substitution, that is always the easiest way to go. So what that looks like is you would just plug in the 4. But in this particular case, if you plug in a 4 here, you get 16 minus 12 minus 4. That'll end up with a 0 in the denominator, and we know that that can't happen. So that does not give me a valid answer. So what you want to do whenever you have a quadratic or anything that is factorable, you do want to factor and see if that helps. So I'm going to rewrite the limit as x equals 4, or x approaches 4. On the top, I have my x minus 4, and then obviously this in the denominator also factors. And you're going to have 4 and 1 and negative 4 and a positive 1. Okay, what that does is notice that now I can cancel, and then I am simply doing the limit as x approaches 4 of 1 over x plus 1. And now I'm allowed to directly substitute that 4 and get an answer. So here I plug in the 4 and I get obviously 1/5. So that is how you do direct substitution. If I was able to just plug in 4, then I didn't have to do any of this business, but I was not able to do that since the denominator would be 0. Okay, so that's one example of how you can find the limit. Next example, they wanted you to do a table. Well, I'm going to go through the graph of this in order to talk about this table. Okay, so doing a graph of a rational function, there are lots and lots and lots of things to think about. So thing about the denominator being 0, those are called restrictions in your domain. So I would have a restriction in my domain at x equals -1 and x equals 4. So there are two different things that can happen on a graph when you have those denominator restrictions. The first thing is you can have a vertical asymptote. And the vertical asymptote in this case is what's left after the canceling. So x equals -1 would be a vertical asymptote. And I'll start doing the graph down here. So at -1 on the x, this is going to be a vertical asymptote. Okay, the other thing that can happen in a rational function is you can have a hole. So it is a particular point that does not have a value and does not have a y value. So when you have these terms that cancel, that indicates you have a hole at x equals 4. Okay, so I'll just say at x equals 4. So I have a hole at x equals 4, and then I would just have to figure out that y. Well, I already did figure it out with this limit, and that would be at 1/5. So I have a hole in my graph at 4, so 1, 2, 3, 4, and 1/5, so somewhere right there. Okay, going on from there, other things that are super helpful are horizontal asymptotes. So there are rules to go with that. The rules are actually indicated over here on page 13 somewhere. Where are they? They're there. So here are the rules for horizontal asymptotes. And what you are doing in this case is you are comparing the degrees of the numerator and the denominator. So if the numerator is less in degrees than the denominator, so if you look at, for example, this guy, you have the degree of the top is 2. Look at the highest exponent in the expression. The degree in the bottom is 3. So the numerator is less than the denominator, so I have a y equals 0 asymptote. Okay, degree of the numerator is the same as the degree in the denominator. That would be this case. So sometimes the degrees are not in standard order. So you do have to just double check. But here's the degree 3. This is also degree 3. So then you just take the coefficients of those degrees, of those leading coefficients, and then you just make a fraction out of them. So this would be y equals 5 over -3 would be the horizontal asymptote. Okay, and then the last case, degree of the numerator is greater than the degree of the denominator. So here you'll see this degree is 5 and this degree is 2. So that means there's no horizontal asymptote. But there could be a slant asymptote. And that occurs when the numerator is exactly 1 more. The degree is 1 more than the denominator, and then you do a division to figure out that slant asymptote. So there's all of those rules as well. So going back to the example I'm talking about here, so horizontal asymptote, so if you notice the degree on the top is 1, the degree on the bottom is 2. So when the degree on the top is smaller, that's when you have horizontal asymptote of y equals 0. So I know my graph has this horizontal asymptote as well. Okay, the general form for a 1 over x graph is going to be like a curve here and a curve here. And you can sort of guarantee where those curves are by finding the y-intercept. So the y-intercept is easy. We talked about this earlier, but you just plug in x equals 0. So if I plug in x equals 0 right here, all of these go away and I get -4 over -4. So that's a y-intercept at 1. So what that indicates to me is that my graph, and maybe I'll do it in a different color, my graph is in this quadrant. That didn't work. My graph is in this quadrant here, going towards that hole, but keeping going, and then this quadrant over here. Okay, so that was a lot of information, but this is all stuff you did last year. Vertical asymptotes, holes, horizontal asymptotes, graphing those rational functions. So that's a basic overview of how to go about that. Now, what they want you to do here is you're going to find the limit using a table. So what you want to think about in terms of what actually a limit means, and 4, this is 4, what this actually asks you to do is what is the y value as you approach x equals 4? So what you have to imagine is it has to match from the left side and from the right side. So you got to imagine this is like a hiking trail and you're on that trail and you're hiking towards x equals 4, and what y value are you approaching? But you have to do that from both sides of x equals 4. So I'm on the hiking trail on the other side of x equals 4. I am hiking and approaching x equals 4. And the question is, what is that y value as I'm approaching from either side of x equals 4? So that's the basic idea of the limit. And so that's what this table is supposed to tell you. So what you can do here is you can put the equation in your graphing calculator. So you go to y equals, and then you just have to be very careful that you put parentheses around the numerator and parentheses around the denominator in your calculator when you put it into the y equals. Okay, so you put that in, you can graph it. You can see that our graph should match that pretty well. But to plug in particular values, you are going to go to that Calc menu and then Value, and then you're going to plug in these particular x values to get out y values. Okay, so I did that. If you want, you could pause and do this yourself. But when you do that, these are the values you get. And I did round them to 3 decimal places. So those are my values when I plug those particular numbers in. What you want to notice here is that these values here are numbers that are just on the right side of x equals 4, because x equals 4 would be right here. And then these values here are just on the left side of x equals 4. So you're getting closer and closer and closer to 4. And here you're going closer and closer and closer to that 4. Well, notice what these y values are. These y values are basically 1/5. Okay, 0.2 is going to equal 1/5. So that is using a table of values to figure out the limit. So you have algebraically, you can just substitute if you can cancel and substitute. You have graphically, where you think about if I'm walking along this trail, what y value am I approaching? What y value am I approaching, even if that y value doesn't exist? And then table-wise with values, this is another way you can look at limits. So that was a lot of information, but that is basically all the stuff you're going to be doing for these next few pages. Okay, so here, again, you're going to do it graphically. So you're going to put those in your calculator and look for the limit at those particular values. Direct substitution, so you'll need to cancel if you have to. The only one that's super hard is this one, rationalize the numerator. And we can go through that some other time. But basically, you're going to multiply top and bottom by the square root of x plus 1 plus 1. And when you FOIL that top and then multiply here on the bottom, the x in the denominator will cancel. But that one's pretty hard, actually. Okay, so that's all of this business, all of this as x goes to infinity. So these ones you're going to do graphically generally. And let's see. Yeah, so generally you're going to do this graphically. So if you think about the horizontal asymptote, if you figure out that, here these are a degree 2 and a degree 2. So my horizontal asymptote is at 4. So as x is going out to infinity, and if you graphed it, it'll look something, you have this horizontal asymptote at 4. But you'll have a graph on this side that goes like that. And you can graph it in your calculator and see that. There's other parts of the graphs as well. But this is x going out to infinity. And you can see the y value that it's approaching would be that y equals 4. So this would equal 4. So that's just, as you're going out to infinity, that's another way to look at, but you're looking for the y value. Okay, and then last thing, going through unit circle work, you do have to know the unit circle. This is a non-negotiable as well. But there's a few things that, there's really only 3 things that you need to know. So you need to know that the radius is 1. So every point that is horizontal or vertical from the center here, this is just at 1, 0. Okay, the 30, 60, 90 triangles. So you're going across and then up. So across here would be root 3 over 2, and then up would be 1/2. All of the 30, 60, 90 triangles are root 3 and 1/2. You might have to change the order, you might have to change the sign. And then lastly, your 45, 45, 90 triangles here. So that is root 2 over 2, root 2 over 2. And root 2 over 2. So if you know these 3 things, you can fill out the whole entire unit circle. Okay, all of them relate to those 3 points. Okay, that's it for now.